we're going to look here at the problem of omitted variables. And to do that, I've got a couple of data sets that I've constructed. These are artificial data, but they're going to allow us to see how our models get affected by leaving out variables that should be in the model. Okay, so we've imported our bias 1 data. First thing I'm going to do is show you guys a graph of our x variables together. Oh, did I forget to run that? I must have forgot to run that. Okay. So bias 1, I'm going to show you a scatter plot of x1 and x2. We'll run this, and our graph shows us that x1 and x2 are uncorrelated. If I told you the value of x1, that wouldn't help you to know anything about the value of x2. Okay, so now let's move into regression, linear models, linear regression. Bias 1 is our data set, our dependent variable is y, and continuous variables are x1 and xy. In this case, we actually have a true model. Because I've constructed this data myself, I know that y is formed by adding 30 of x1 and 20 of xy, and then an error term with a standard deviation of 10. And so what we should find when we run this data, when we run this model, is essentially that we get all of those results back. We've got an R squared of 0.9853, a root mean squared error of 10.29, and our parameter estimates for beta 1 and beta 2, the parameters associated with x1 and x2, are just about right, 30.09 and 19.84. So this is our baseline case. Everything's going great so far. We've got our two variables in the model that should be in the model, both x1 and x2. Now let's screw up. So what we're going to do now is take out x2. Let's suppose our data for variable x2 was not available. How would that affect our results? Well, in this uncorrelated case, some things go well, some things go poorly. Let me give you the good news first. Our parameter estimate is still just about right. Our parameter estimate is very, very close to that correct value of 30. But take a look at our R squared and root mean squared error. 0.4791 is our R squared, our root mean squared error is 61.15. These are disastrous. Our models become 6 times less accurate at prediction. It's explaining less than half of what it previously explained. We're going to see the same thing if we leave out x1. So I'll delete x1 now, add x2 back in, run this. And what you're going to see is now a beta 2 of around 20. Yep, 19.87. But again, at root mean squared error and R squared are disasters, just about as bad as they were before. So in the uncorrelated case, leaving out a variable doesn't affect the parameter estimates, but it dramatically affects the predictive power